Now, am I audible, guys? Now? Now, am I audible, guys? Hello, 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 hello. Only one person, Narendra, and me, only two people. What about the other guys? I think people are becoming like, night owls. They just prefer reading in the nights and, sleeping at 12, 1 and not waking up by 7 also. So, you will sleep by 12, 1, 2 and then you will wake up by 10 o'clock in the morning, 8 to 10. Huh? It's okay, there is no issues in that. Other guys, please do comment, whoever is that present over here. I tried both evening sessions and morning sessions, and the crowd was not that much different. In evening session also maximum crowd I got is 10 to 15 only at a stretch. In morning session also the same thing, but only 2 to 3 people are constantly watching this. Hi guys, please do comment. Suresh Vade, good morning Suresh. Good morning Suresh. Any other guys, please do comment. There are 6 views, so one is me, another one is Suresh, another one is Narendra. What about the other 4 guys? Why don't you comment? If you comment, then only I can understand. Generally, in the recorded form also, I see some after after some 24 hours, 3 to 4 days, there will be some 400 views. There will be 400 views, but there will be only 30 likes. Why? Rest 360, 370 people, they don't like me. At the same time, there is no dislikes also. That means, what is your view? You want to like or you don't want to like? You liked it or you don't like it? I just don't understand here. Please be very much clear whether you like the video or don't like the video. If you like it, please like it. If you don't like it, don't dislike it. So maybe that's the reason you may not be liking it, so that's why you're not disliking it. Good morning Mahima, Saroj, good morning. Fine guys, so today we'll be starting with traction and tractive effort of locomotive. Traction and tractive effort. Traction and tractive effort. Traction and tractive effort of locomotive. Fine. So whenever I am talking about train, there will be a locomotive or engine and there will be wagons. In a train, there will be a locomotive and there will be wagons. So if I consider this is the locomotive, this is locomotive, and this is wagons. So when I talk about total weight of the trains would be equals to weight of locomotive plus weight of wagons. All these things are connected like this. Fine. It is the locomotive. Locomotive means that is the engine that actually pushes the train. Fine. So total weight of the train equals to weight of the locomotives plus weight of the train. Weight of train equals to weight of locomotive plus weight of wagons. Weight of locomotive plus weight of wagons. So total weight of train would be equals to weight of locomotive plus weight of wagons. So these are the things that you should remember in the mind when we are what is things remembering in the mind. So this is the idea. Weight of the train, whenever I am talking, it is weight of the locomotive plus number of wagons, weight of each wagon multiplied with weight of each wagon. Fine. So whenever we are talking about traction, that means indirectly tractive effort means the effort that is generated, or the effort that should be generated by the engine to overcome the resistance for the train. The resistance can be because of many reasons. Resistance can be because of many reasons. So first thing, if I talk about total resistance, it is the resistance offered by the train. It is the resistance offered by train and various other reasons for the movement of the train, for the movement of the train. So resistance offered by the train for, and also various reasons for the movement of the train. In total resistance, first one if I take, it would be train resistance. In that there will be many criteria. The first one is resistance independent of speed. So when you are saying resistance independent of the speed, this is generally given as RT equals to 0.0016 W. 0.0016 W, where W equals to weight of train in tons. RT equals to resistance in tons. Resistance offered by train in tons. This is resistance independent of the speed, 0.0016 W. This is resistance independent of the speed. Next, why? This can be occurred because of many reasons. First one is journal friction. It can be because of many reasons. It can be because of many reasons. First one is journal friction. Journal friction means friction within the friction within the locomotive, friction within the wagon wheels, friction within the body. Like friction within the body, the same thing, friction within the body of the train is considered as journal friction. Okay. So journal friction is friction within the internal parts of locomotive wagons, etc. Next, there will be friction between rails and wheels also. So that could be one of the reasons. Friction between rails and wheels. Friction between rails and wheels can also be some part of that. There will be resistance for the movement. Friction between the rails and wheels, and then fine. These are the major two reasons for train resistance, that is resistance independent of the speed, is calculated something like this. Resistance independent of the speed will be because of all these things. Next one is resistance dependent on the speed. B is resistance dependent on the speed. Resistance means, the vehicle or the train can't move. What are the forces that is resisting for the movement of the train? We are calculating that. Okay, so resistance dependent on the speed, which is generally given as RT2. I'll write, if I take that as RT1, this would be RT2. Next one is RT2, that is 0.408 W into V, where W equals to weight of train in tons, and V equals to speed of train in kilometers per hour. Next one is RT3. So RT3 would be equals to 0.606 WV square, where W is the weight of the train in tons, V is the speed of the train in kilometers per hour. RT2 would be equals to resistance in tons. So this one is also where W equals to weight of train in tons, and V equals to speed of train in kilometers per hour. Fine. So this is speed of train in kilometers per hour. RT3 equals to resistance in tons. This is here wind speed is not considered. Wind speed is not considered. So finally wind speed is not considered. So total train resistance, if I talk about train resistance, RT, that would be equals to RT1 plus RT2 plus RT3. RT1 would be equals to 0.0016 W. This is 0.408 WV, 0.606 WV square. This is how you are going to get train resistance. In total resistance, train resistance is one part. So train resistance is calculated something like this, where W is the weight of the train. So W would be, weight of the train would be equals to weight of locomotive plus weight of wagons, weight of locomotive plus weight of wagons. Okay, so this is train resistance. Fine. So the train resistance is this. Next one is resistance due to profile of the track. Next, second one is resistance due to profile of the track. Resistance due to profile of the track. If I consider resistance due to profile of the track, so in that there are two things: resistance due to gradient, and resistance due to curve. Resistance due to gradient and resistance due to curve. Gradient means longitudinal slope. Okay, so indirectly that is vertical slope. Fine. So if this is W, weight that is acting downwards, this will be W sine theta. If I take this as theta, this would be W sine theta. Fine. Resistance will be acting in this direction. So generally, resistance due to gradient RG. Resistance due to gradient is generally given as W sine theta. For small values of theta, sine theta is approximately equal to tan theta, right? For small values of theta, sine theta is approximately equal to tan theta. So resistance due to gradient Rg would be equals to W tan theta. This is resistance due to gradient. Rg would be equals to W tan theta. Next one is resistance due to curve. Resistance due to curve. So if I consider resistance due to curve, what exactly the resistance is? If you see in curve, the distance travelled on the outer track will be different from the distance travelled on the inner track, right? We all know this. Distance travelled by the outer track is different from distance travelled on the inner track. So the distance travelled on the outer track is different from the distance travelled on the inner track, because of which there will be skid and slip . So like the distance travelled on outer track is different from distance travelled on the inner track, and during that movement also the flange can hit the tracks, because of which friction is developed. So there will be some skid and slip. Because of that, skid will be what? Skid will be like when you apply the brakes, it travels some amount of the distance, where longitudinal movement is more than circumferential movement, that is skid. Slip would be during the starting of the vehicle, it will keep on rotating it but it can't move, right? So these type of things will be seen over here, because of which the friction is developed, resistance is developed. So that resistance is resistance due to curve. Okay, so when train is moving on a curved track, train is moving on a curved track, distance traveled on outer track, the distance traveled on outer track is different from distance traveled on inner track, due to which some resistance will develop. In the brackets you can write mainly because of skid or slip. Mainly because of skid or slip. So how it is given, the resistance that is developed, generally it is given as resistance due to curve, that is equals to 0.304 WD degrees. This is for broad gauge track, and this one equals to 0.303 WD degrees for meter gauge track, and this is equals to 0.302 WD degrees for narrow gauge track. Good morning. अभी सर IRMS के लिए VOK प्रोटेस्ट करना चाहिए. Good morning प्रशांत काकरला. What is that, yeah? Fine. So this is curve resistance. Curve resistance equals to 0.304. All these things are formulas here. So it's like when the vehicle is moving, train is moving, the flanges will hit the track, right? Because of that also some amount of resistance will develop. So there will be skid and slip, all those things will be there. This is a resistance due to curve. So we have seen resistance due to gradient, and we have seen resistance due to curve also. Fine. Next one is resistance during starting and acceleration of the vehicle. That means when there is starting, when the locomotive starts, there will be some amount of resistance it has to overcome, and when it's accelerating, that means when you are increasing the speed, then also there will be some amount of resistance. So that would be a third thing. First one is train resistance, second one is resistance due to profile of the curve, that is because of the gradient and because of the horizontal curves, and third one is resistance due to starting and acceleration. Resistance due to starting and acceleration. So in that resistance due to starting, is generally equals to RS, that is generally given as 0.15 WL. This is for locomotive, and that is equals to 0.005 WW. This is for wagons. All many empirical formulas are there. You have to just remember. You don't have a choice. Fine. So this is resistance due to starting, during starting or due to starting. Next one is resistance due to acceleration. So generally resistance due to acceleration, R acceleration equals to 0.028 W V2 minus V1 upon T. Where W equals to weight of train in tons. in tons. V2 and V1 are the speed before acceleration and after acceleration. So V2 and V1 are both are speed in kilometers per hour. Speed before acceleration, speed after acceleration, speed in kilometers per hour. T is the time taken for the acceleration. Generally, you will be considering that in seconds. Fine. So this is resistance due to acceleration, resistance due to starting, resistance due to acceleration. This is your third one. And fourth one is resistance due to wind. Resistance due to wind. That means because of wind force, because of the wind force, when train is moving like this, wind will offer some amount of resistance. Like when you are moving like this, there will be some amount of wind that is offering. So resistance due to wind, resistance due to wind, Rw is generally given as 0.4017 A into Vw square. A multiplied with Vw square, where A is the exposed area of train, exposed area of train in meter square. Vw is equals to speed of wind in kilometers per hour. Vw equals to speed of wind in kilometers per hour. So this is the different resistances. There will be resistances because of four things. So if I talk about total resistance, then it would be resistance due to train, and that is resistance due to first one is train. In resistance due to train, RT that I have shown you, that equals to 0.0016 W plus 0.408 WV plus 0.606 WV square. This is because of this. Next one is RG. RG would be equals to W tan theta, and RC. RC would be three things: 0.304 WD degrees, 0.303 WD degrees, and 0.302 WD degrees. For different tracks, you will be finding out this. So RT plus RG plus RC plus RS plus, that is resistance due to starting. Resistance due to starting would be 0.15 WL plus 0.005 WW. WW weight of wagons, WL weight of locomotive. Fine. Next one is, this is RT, RG, RC, RS, R acceleration, and then R wind. Because of the wind, this would be equals to 0.4017 A into V square, A into V W square. Everything is in tons. It's not in kilonewtons and anything. Units are important. Everything is in tons. R acceleration I have just given to you, that is 0.028 W V2 minus V1 upon T. So this is how you are going to find out total resistance. So once you find out total resistance in the examination, if all these things are neglected, the total resistance will be taken equals to train resistance. If all the other things are also given to you, then consider all those things. Fine. So this is how you are going to find out total resistance. Any doubts in this? You can ask me. गुड मॉर्निंग भास्कर त्यागराजन. IRMS के लिए भी एक प्रोटेस्ट करना चाहिए, या डू दी प्रोटेस्ट. आई एम ऑलवेज विथ यू, डोंट वरी अबाउट इट. एनी डाउट्स गाइस? Any doubts? Good morning. Miki Kumar. Fine. So this is one thing, and I hope the units are very much clear with you. T is in time in seconds. I think I have given that. Time in seconds. Everything is in tons, tons, tons. Resistance due to curve, resistance due to gradient, train resistance. This is atmospheric resistance. Name is not given, sorry. Atmospheric resistance. Wind speed is not included in this. This is atmospheric resistance. Fine. So these are the different things that you will consider. Next one, once atmospheric resistance and all those things are given to you, next one is tractive effort. Tractive effort. That means that is the different resistances you have. That is the different resistances you have, and you have to apply the force to overcome all these resistances, right? You have to apply the force on the wheels to overcome all these resistance so that the vehicle can move or the train can move. So the force applied by the engine to overcome the resistance for the movement of the train is called as tractive effort. The force applied by the engine, the force applied by the engine, to overcome the resistances, by train for the movement of train. So to overcome all the resistances, the force applied by the engine is considered as tractive effort. Generally, how exactly you will be finding out tractive effort is? Tractive effort is the effort that is applied on the wheels. And if you remember, generally when train is moving in some movies, they will show you that steam engine piston is moving like this, right? So if you consider steam engine, what happens is there will be movement of cylinders and piston, right? Because of movement of cylinders and piston, the wheels will rotate, right? So the tractive effort generated in the cylinders on piston is converted as tractive force in the wheels, right? So if you consider steam engine, I am not considering electrical engines here, I am considering steam engines. So if you consider steam engines, what exactly happens is, in the steam engines, the cylinders will be, in the cylinder there will be pistons. In the cylinder there will be pistons, and pistons will keep on moving. Pressure applied on the pistons will be different, right? If P is the pressure applied, D is dia of piston, and length travel would be, let us say, some L. This will be converted in the form of tractive effort on the wheels. I am not going in depth in this, I am just giving a basic idea, because development of steam engines is not our thing. It is mechanical part. I am not worried about it. The idea is, if you consider the steam engine, the piston will be moving upwards and downwards in the cylinder. Because of movement of piston, the vehicle will rotate. That energy will be converted into the mechanical energy, right? That force is called as tractive force, that is generally given. Fine. So let us take example. You can write down. Let us take example of steam engine. Here we are using steam engine. If it is electrical engine, the electrical energy will be converted into mechanical energy for the movement of the trains. Fine. Let us take example of steam engine. Steam engine where tractive effort is generated in cylinder on piston and converted into tractive force on the wheels. Tractive force on wheels. So how exactly you are going to calculate is power generated in steam engine. Power generated in steam engine. So power generated in steam engine would be equals to force multiplied with distance. That is traveled. So force would be pressure multiplied with area. Area is pi by 4 into d square, and distance traveled would be 1L and another L. If it goes and it has to go and it has to come back, that is one full cycle. Okay, so multiplied with 2L multiplied with n number of cylinders. That is, for one cylinder it will not be one cylinder, there will be n number of cylinders. So n equals to number of cylinders. So this is n. This is power generated in the steam engine. This power generated in the steam engine equals to work done by the wheels or work done by the tractive force. That is generally given as work done by tractive force. That equals to force multiplied with distance. So if for one movement of the piston, the distance traveled would be 1 perimeter. So that distance would be 1 perimeter. Distance means pi multiplied with d. So that means if piston goes and comes back, the wheel travels by a distance of pi d. That means one full circle rotation will occur. Fine. So tractive effort multiplied with TE multiplied with pi d. So the thing is, this power generated in steam engine is converted as the work done by the tractive force. If I equate both the things, TE multiplied with pi d equals to P multiplied with pi by 4 d square multiplied with 2L multiplied with n. So simply what you can write is TE tractive effort equals to P multiplied with pi d multiplied with 2L multiplied with n. This is the tractive force that is generally generated. This is the tractive force that is generally generated. Fine. Any doubts up to here? You can ask me. Please provide PDF notes. Which PDF here? PI will not be there. PI will not be there means what? Sorry. This is dia of the wheel. dia of the wheel. So this would be pi times capital D. D is the dia of the piston, this is dia of the wheel. This is dia of the piston, pi by 4 into d square. This is pi d square upon 2d. Sorry, d is the dia of the piston and small d is the dia of the wheel. Please be clear with it. Capital D is dia of wheel, and small d is dia of piston. Anyway, that is given to you. So, what is your doubt? Pi nahi hai. Where I have written pi r? Okay. P multiplied with d square multiplied with L multiplied with N. There will be many energy losses during conversion. Yeah, of course, I am not considering it. I am just giving some basics. Assuming losses are equal to 0. Losses are equal to 0. Assuming losses are equal to 0. This is TE, tractive force. Tractive force is indirectly proportional to the dia of the wheel. If dia of the wheel is more, tractive force will be less. And generally velocity of the vehicle will be more. If dia is more, velocity will be more. Fine. Similarly, if dia is less, tractive force will be more and velocity will be less. So we need both velocity as well as sufficient amount of tractive force to overcome the resistance. So dia of the wheel should be selected in such a way that it provides sufficient tractive force to overcome the resistance, and there will be sufficient velocity also. Fine, you should balance both the things. It's not that you will balance only one thing, and if velocity is less, if it is overcome the for resistance, it's okay. If velocity is less, it's waste of time. If speed is more but it doesn't have sufficient force to pull, then also it is waste. Fine. So dia of the wheel, you can take a note. Dia of the wheel should be selected. Dia of the wheel should be selected in such a way. Dia of the wheel should be selected in such a way that sufficient tractive effort is generated. To overcome the resistance for movement of train and sufficient speed is also developed. Fine. Any doubts in this? You can ask me. Only 6 people are watching. Please do like, share, subscribe with as many people as possible. Any doubts, guys? No doubts? Suddenly there are 6 members only now. Initially there were 10, now it is 6. Fine. So this is tractive effort. Next one is hauling capacity. Hauling capacity. This is the locomotive. Fine. Hauling capacity is the maximum friction that can be developed between the rails and wheels. Maximum friction that can be developed between the rails and wheels is considered as the hauling capacity. Maximum frictional force that can be developed between the rails and wheels. Generally, let us say weight is WD, weight of the driving wheels is WD, then hauling capacity is the frictional force. If it is moving like this, then frictional force is, let us say, developed like this. So this is the hauling capacity. So hauling capacity, it is the maximum frictional force that is developed between rails and wheels. Maximum frictional force that is developed between the rails and wheels. So idea is very simple. When you are starting the vehicle and you are trying to move, first it has to overcome the frictional forces. At the same time, during the starting of the vehicle, frictional force will be in the direction of movement, right? So the frictional force also should be sufficient enough so that it overcomes all the resistance. This hauling capacity should also be more, if it should be more to overcome all the resistances. Fine. So this also helps in movement of the train. Apart from, even though if tractive effort is more than total resistance, the train should have proper hauling capacity so that it will be stable enough. Fine. Proper friction should be developed. So it is the maximum frictional force that is developed between the rails and wheels. Generally, if WD is equals to weight of single pair of driving wheels, if n equals to number of pairs, then hauling capacity is generally given as mu multiplied with n times WD. Sometimes this is also given as mu multiplied with n times R, where R is the resistance. Fine. So this is how you will be finding out hauling capacity. This is the maximum frictional force that is developed between the rails and wheels. Generally you will be seeing locomotive which is designated as, 462 or whatever it is. What exactly designation of locomotive 462 means is, there will be 4 front wheels and 6 driving wheels and 1 back wheel. 4 front wheels, this is 4 front wheels. Tomorrow when you see, you will understand this. Whenever if you are boarding a train, see that locomotive 462 means there will be 4 front wheels and 6 driving wheels, and 2 back wheels. 2 back wheels. 6 driving wheels means that equals to 3 pairs. 3 pairs of driving wheels. Indirectly 3 axles. For one axle there will be 2 wheels, right? So there will be 3 axles, 3 pairs of driving wheels. If there is a number of pairs is 3. Fine. This is 6 driving wheels. Locomotive 462 designation, if it is given, that is the meaning of it. Okay. And this is the hauling capacity. Generally, from design point of view, whenever you are designing, minimum of hauling capacity and tractive effort. Minimum of hauling capacity and tractive effort should be more than total resistance. Minimum of these two things should be more than total resistance, so that train will be moving without much discomfort. This is the idea. Fine. Any doubts up to here? you can go ahead and ask. Zero dislikes. If you want to dislike, you will dislike. What is there in that? Any doubts, guys? Any doubts? No doubts. Fine. Try to solve a question. Calculate maximum permissible load that a broad gauge steam locomotive can pull with three pair of driving wheels with axle load of 22 tons each on a straight level track at a speed of 80 kilometers per hour. At a speed of 80 kilometers per hour. First one is on a straight level track at a speed of 80 kilometers per hour. Take mu equals to 0.2. Please solve it. What is the doubt, Narendra? You are saying S? How R is used instead of WD? R means, okay, I have not shown it. If this is WD, the resistance will be developed in the upward direction, that is R. So indirectly R would be equals to WD, that is the meaning of it. Generally you will consider normal reaction, right? If weight is acting like this, normal reaction will be the N, same thing like this. If WD is acting like this, R is acting upwards, hauling capacity would be equals to mu multiplied with N times WD or R. That is the meaning of it. Fine. Where mu values will be generally in the range of 0.1 to 0.3. This is and all longitudinal friction. Don't compare this with a lateral friction. Lateral friction in super elevation, we have taken it as 0. This is longitudinal friction. Okay. So this is the idea. Please solve it. Please solve the question. Nine people are watching. It's okay. What can I do? What is the answer, guys? Make it fast. Okay, sir. What is the answer? Give me the answer instead of okay, sir. Two two three eight tons. One person has given me the answer. Great, great, great. 13.2 tons. This is even great. Fine, yes. So the thing is, First he is saying straight level track. Straight track level track means there is no curve, there is no gradient. Straight track level track, there is no curve, no gradient. So weight of each axle load is 22 tons. We can't calculate track to effort here, we can only calculate hauling capacity. Hauling capacity HC. HC would be equals to mu multiplied with N multiplied with WD. Right? Mu is 0.2. Number of pairs of axles 3. WD. WD is how much? 22 tons. 22. So what is this value? 66 multiplied with 0.2. 13.2 tons, right? tons. Hauling capacity equals to 13.2 tons. And for straight means no gradient, level track means no curve. Fine. So if I equate hauling gradient equals to total resistance, that equals to RT. 13.2 tons equals to RT. RT is 0.0016 W plus 0.408 WV plus 0.606 WV square. V is given to you as 80 kilometers per hour. 80 kilometers per hour. Fine. So that means what you have to calculate? You have to calculate W. Substitute and calculate. 13.2 equals to 0.0016 W plus 0.00008 W. V is 80 plus 0.00006 WV square, that is 80 square. From this, what is W that you will be getting? 0.0016 plus 0.12348 multiplied with 80 0.408 multiplied with 80, that is 0.0064.1234566 multiplied with 80 multiplied with 80 plus 0.0064 plus 0.0016, that equals to 13.2 equals to 0.01184 W. 1184 W. So W would be equals to 13.2 upon 0.01184. 13.2. So that would be equals to 111.486 tons. Approximately 1115 tons. So it can take up to a 1115 tons of weight. It can move 1115 tons. You can understand how many kgs. Multiply that with 1000. That much huge amount of kgs it can pull off. Fine. Any doubts in this? You can ask me. Kushbu ja. He said WD is weight of one pair. It's not weight of single thing. It is single wheel axle, means axle load means for one axle there will be two wheels. So for one pair it is 22 tons. For three pairs it would be 3 into 22. Fine. This is the thing. in the same problem, in the same problem, take another question. What would be the reduction in the speed? In the same problem, find out what would be the reduction in speed if train has run on a rising gradient of 1 in 200. What is a reduction in speed? What is a reduction in speed if train has to run on rising gradient of rising gradient of 1 in 200. If train has to run on rising gradient of 1 in 200, what is the reduction in speed? For the same question, we have calculated W, trying to find out V right now. So if it has to run on a rising gradient of 1 in 200, please calculate it. Only 17 likes. My mistake, your mistake, everyone's mistake. Only 7 people are watching. Please do like, share, comment, subscribe. Do everything, do whatever you want to do. I think transportation will be started in your CEME class also. A new faculty came. Should I have seen that? That is for Hindi people, Hindi guys. What is the answer, guys? एक से ज़्यादा like कर सकते तो हम करेंगे. See, it's not about only one people. There has to be many people, right? And you please start RCC after this. I haven't got any orders. The order for me is to complete transportation engineering recordings. I haven't submitted my transportation engineering recordings, and I have to start my engineering mechanics recordings also for PDGD courses. So yeah, I have got that much huge work. I think till I have submit all those things, they are not going to leave me. Let's see how it goes. What is the reduction in speed? सर रहने दिए, खुद को रिस्क में ना डालें. We can adjust. Prachi is adjusting a lot. It's not like that, but I should not start. There are other faculty, right? So yeah, I should not start. And obviously you'll get bored of me if I take all the 14 subjects. One day or other you'll be like, same guy, same type of teaching, same type of language. You get bored. Like, different years I can do different subjects, but same year 14 subjects with same batch will be quite boring. Good morning, Gitanjali madam. जो तीख है तीख करके हेडेक कर देते हैं, जो ठीक है ठीक करके हेडेक कर देते हैं मतलब क्या है प्राची? थैंक्स फॉर दी लव नरेंद्र, लेकिन ज़्यादा लोग हैं वो अच्छे से पढ़ाते हैं, and there are people who like other guys also. In India there are lakhs of people, and I have got only 17 views. In that 17 views only 8 people are, 17 likes, and in that only 8 people are watching right now. That means I have got only 8 people of crowd. I was able to pull 8 people out of lakhs of people. So that means if I take minimum 2 lakhs, right, in a year 2 lakhs people will be giving engineering services. I was able to pull off 8 people or 10 people. That means 1,99,990 people don't like me. Huge number. If it's like I'm getting 1 lakh views, then it's like, okay, 50-50. I'm not even in consideration. 0.1%. क्यों प्राची, मैं वैसे पढ़ाता हूँ कि हर बात में टीक टीक? I don't think so यार. After completion of a concept then I'll ask whether you have any doubts. ठीक है, उसमें क्या? See, don't compare यार Narendra, don't compare. Everyone has their own things. Even it's not like I created all the subjects. Even I studied from other professors, and then I developed my own content and I came back. So I'll not, there are many people, maybe you might not have found them, but there are many people, many places in India who teaches different subjects in a better way. But I'll be more focused on exam point of view, why we are here to crack the examination, right? I'll not go deeper into the things. That's the thing. Anyway, what is the answer? It's been 5 to 10 minutes I have given to you already. 5 minutes I have given you already. ठीक है, leave it. I am not asking the names and all those things. That is up to the time. Sometimes they might not able to, like, impress you. There are many cases like I am not able to impress many people. Even in this platform also you can see only 10 people are watching. Initially in structural analysis there were huge number of crowd from South India, and suddenly they were not present in transportation, and there were other guys also. So, and suddenly they are missing, and at the same time the number of views that is coming over here, I have to convert this into the people who is purchasing PDGD courses. So there is a huge thing. It's not only one thing that people should be worried. There are many things that the thing is, we are showing it here how we are going to teach, and we'll be asking you to buy that PDGD course for GATE engineering services, and then so how exactly things will work, all those things you have to go through that. So the thing is very much huge thing. So some people, it's like we also have pressures. So different teachers have different pressures. So based on that they will work. I'm taking risk and I'm teaching all those things, but in actual I should have simply went with the flow of clearing the basics problems, but in depth I'm teaching, so that this is the only chance that you get crash course or free course. So I'm just wanted to complete, give a clear idea of what is what. Okay, whatever I'm teaching, I'll not say that I have taught everything in a full manner, but whatever the concept I have taken, I have taught it in a better version. That's what I can say. Better version. Better version. So yeah, every teacher is different in his own way. Some people might like them, some people may not like them. So, but who is the best teacher? If you ask me, the person who is able to shape out the future of students. Like, if I am able to generate the ranks from you, then I am the best. If not, I am the worst. As simple as that. At the same time, generating the ranks, I have to give you the self-confidence to live in the life. So these are the things. First thing is, I have to give you the self-confidence to survive in the life. Second one is to create ranks. Create ranks is very much important. Showing the results, that is what shaping out of the future. Like, you understood the concept, but you are not able to produce the ranks. It's of total waste. You have to understand the concept, you have to like the concept, you have to generate the ranks. Idea is what, why you are sitting early morning over here, to create ranks, get the ranks, get a proper job in the life, and see a way in the life. So that is the idea, that is why I am here. So my idea or my view is very simple. Wherever I go, wherever I teach, idea is very simple: generate decent amount of ranks, so that it will shape out the future of kids. And your idea should also be like, of course, if you like a subject, that's well and good, but don't waste your time only in one subject. Your idea is to get the rank, whatever it is, whether it is state services, GATE, engineering services. First rank is always better. So for that, you need all 14 subjects, not only one or two subjects. So 14 subjects is important. Get the first rank and shape your future in a proper way. That's what I'll say. Thank you, thank you. Thank you, Bhaskar. So that's what I'm saying. Idea is to get the rank. So don't deviate from your things. Like Narendra is having July 4th is your examination. So what have you studied till now? Hardly there is 15 days for your examination. By now you should have completed all your syllabus. Keep on practicing the previous year's questions and go and perform better. If you get a job, like day before yesterday, I got a message from my student. He's from Raipur actually. He was not able to clear GATE. He got seat in some of the IITs, but he cleared state services and he is doing that. And he said, sir, it's because of you I was able to do that. I want to do something for you. I received that message. So when I received that message, I was like, I have this, okay, I'm helpful for creating a future for him. He's saying, sir, I am the youngest person who joined this, so there is possibility of getting in another 5 to 6 years I'll be promoted, and there is possibility of getting the promotions, so I'll be in a better position, sir. So I was like, okay, have fun, take care of you and your parents, and try, if possible, try to reduce the corruption, right? So that's what I said. So same thing, I expect these type of messages. There are other messages also which I have received. Sir, I was not able to get into the GATE engineering services. After that I shifted to SSC JEE, that also I didn't get, and then I have shifted to non-technical. I was not able to do anything, sir, and finally I went to some private job for 10,000, 8,000 rupees. So when I read those type of messages, it's like quite disheartening. Okay, something went wrong with him. Something went wrong in my teaching, so that I was not able to shape out the kids. It's like an exam for you, but what we say is it's like a future for you. It's like a future opportunity. I will not say if gate is not clear, your opportunities are closed. No, one of the opportunity is closed. That's what I'll say. One of the opportunity, nice opportunity is lost. It's like, of course, he went to the private, he'll be starting with 10,000. After that he can move. If he works hard, he can get some 50 to 60,000 also. It's not a big deal, but the thing is, these are best opportunities are closed, and then he has gone to that opportunity, and tomorrow he has to go for some until and unless if he invests in his mind, he can't reach his heights. So I'm more selfish guy. If 100 people are teaching, are studying from me, I expect all 100 people to get a good jobs, all 100 people to be settled in the topmost position. That is what I expect. It's not like only 10 people will be happy, 90 people will be, no. I want all 100 people to be in the topmost, wherever that is, respective positions, whether it is GATE, engineering services, state services, private jobs, anything. I want him to be at the top. That's what I expect, right? So that is what is okay. I'll not say I am the only one who created all those things. One stepping stone, just one stone, one part in his future. In designing the kid's future, I was one part. So that's what I can say. So and that's what I expect. Okay, if let us say I'm teaching only 2 subjects or 1 subject, or I'm taking only a motivational class for you, what I expect is, I expect only this. At least I'll be a small part in your success. You can fail. Failure is a part of success, only stepping stone for success. Like this year you are not able to get the GATE, but next year at least you should work hard. You should rectify your mistakes, then get the better job. GATE, engineering services, state services. There is nothing wrong in 2 to 3 years. In 2 to 3 years, at least you should clear one examination. If you ask me, max in 2 to 3 years, at least you should have a job. See, settle before 25. You can experiment with life before 25. After 25 you can't. There will be huge amount of pressures on you. You have to get the job by hook or by crook. You have to get the better job. Then only there will not be family pressures on you, family tensions on you. For girls, you'll be married. There will be marriage pressure for the girls. If you don't have job, they'll ask you to get married, because see, they'll simply say you're not able to clear, so go and get married. Fine. And even you yourself will feel like, okay, let's get married, something like that. And for boys, like after 25, it's like huge pressure. Parents they'll say you're not settled, and financial tensions, everything will be on you. So if you get a job, you'll come out of all those things, you can have fun. So till 25, experiment with your life, whatever that you want to do, GATE, GRE, GMAT, CAT, and whatever that you want to do, and even the bank examinations, whatever it is. Before 25, do all those things. But once, if your age is 25, you should have a job in your hand. If you don't have a job, life will be miserable, literally miserable life will be. So please be serious. When, of course, you can relax, but you have to be concentrated and serious. Why I am saying all these things? From personal experiences, I'll say all these things. Not only I have seen many people who are not settled at this time of 27, 28, and even for the basic money they are suffering a lot. And if you see India is not moving in a forward direction. We are not generating that many private jobs in India. So if you are not generating private jobs, that means we are dependent only on government jobs. So there will be huge amount of, there is possibility of unemployment. If private jobs is not developed, then there is possibility of unemployment that can happen in India. So be cautious, take a proper step and reach to the heights. Be serious. Up to 21, enjoy your college life. Up to 21, enjoy it. 1 year, 2 years, 3 years max. So work hard, change your lifestyle, work hard, eat, sleep, study, repeat, get a job, and then reach the heights. Fine. Anyway, huge amount of motivation. What is the answer for this? Same thing, hauling capacity equals to total resistance. Here there is a gradient. Tan theta would be equals to 1 upon 200. Tan theta equals to 1 upon 200. So this is 13.2 equals to 0.0016 W plus 0.408 WV plus 0.12346 WV square plus W tan theta. What is W? W we have just calculated. 1115 tons. 1115 tons. From this, what is the speed V? You will get a quadratic equation in V. Quadratic equation in V. Substitute it and tell me what is the value of speed that you are getting. Please substitute it and tell me. Solve the equation and tell me. Thirty-one point 86. What is the speed? 48.13 kilometers per hour. 48.13 kilometers per hour. So reduction in speed. Reduction in speed equals to 80 minus 48.13. That is how much? 79 kilometers per hour. What is the answer you are getting here? Make it fast. This is 31.87 kilometers per hour. Reduction in speed. Fine. This is one thing. Next one is, what would be the further reduction in speed? What would be the further reduction in speed? What would be the further reduction in speed? What would be the further reduction in speed if train has to run on 4 degrees curve? If train has to run on 4-degree curve, what would be the further reduction in speed if train has to run on 4-degree curve? That means there will be gradient and there will be curve also. Then hauling capacity would be equals to total resistance, that is hauling capacity equals to 13.2 tons. This is a broad gauge track. So broad gauge track, this is 0.0016 W plus 0.408 WV plus 0.123456 WV square plus W tan theta plus 0.304 W D degrees. D is 4 degrees. Substitute and tell me the value of what is V. Hauling capacity equals to total resistance. Total resistance. Prachi, it's not like that you will message me or you will not message me. I will message you like what is the result and I will go underground and all those things. It's not like that, yaar. The thing is, if you fail, no worries. If you fail, no worries. The thing is, next should be your success. Learn from your mistakes, correct your mistakes. Of course, on that day or 2 days, 3 days, you will be sad. After that, rise. Rising after fall, it should be a huge thing that you should hit the sky. Fine. Okay, that means this year you have not got. Next year, your rank should be like first rank. You should hit very harder. So it's not like if I don't go, I'll go underground, I'll sleep, I'll do that, that is waste. This is just one examination. If not this year, next year. Or if this year, hit it hard. That should be your idea. It's not like I'll go down, I'll go there, I'll go here. What is the meaning of it? Nothing. Just if there is fall, there should be rise. If not, go and hit it hard this time. Give all your 100%. That's what I'll say. Give all your 100%. You'll reach your heights. Because this is in the same question, this is the same question, that's why W would be same. Okay. Sir, what about job in abroad? in abroad you will be having the jobs here, basically in Dubai. For civil engineers in Dubai and UK you are having best opportunities, but you should work hard. If you work hard in Dubai, they are paying like 5 lakhs per month also. Maximum is 5 lakhs per month for a manager over there. You will be getting 5 lakhs also. 5 lakhs in Indian currency. So yeah, Dubai also it will be like that. Only 4 people are watching. Just because I was telling some shit, people left. Fine, fine, fine. I'll take care of it. It's okay, no issues. Now give me this answer. In Germany or other places, I like people to stay back in India. What is the answer? What is the further reduction in speed? Please give me the answer. Reduced speed is 35.85 kilometers per hour. So this is equals to 35.85 kilometers per hour. Reduction in speed, reduction in speed equals to 80 minus 35.85 kilometers per hour. That is how much? 44.15 kilometers per hour. This is the reduction in speed. So according to the equation, whatever that is asked, you can go taking the resistance, different thing. If they are asking starting and acceleration resistance also, you have to take starting and acceleration resistance, wind resistance also if it is given, consider all those things. This is how you solve these type of questions. Fine. Next one is gradient. 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 We have already discussed gradient in highways. Gradient is the longitudinal slope that is provided. Gradient is the longitudinal slope. Longitudinal slope, or you can also say vertical slope. Vertical slope. So there are different types of gradients. First one is a ruling gradient. Ruling gradient. So in ruling gradient, what exactly you will see is, this is the design gradient based upon the general conditions, right? In highways also I said this is the maximum design gradient that is provided based on general conditions. Fine. So ruling gradient, this is the maximum design gradient that is provided based on general conditions. That is provided based on general conditions. Maximum design gradient that is provided on general conditions. So ruling gradient on planes. Ruling gradient on planes. Plane surface. Planes means plane surface. It is 1 in 150 to 1 in 200. 1 in 150 to 1 in 200. On mountains, it is 1 in 100 to 1 in 150. In mountains, gradient is more compared to that of plane surfaces. In plane surfaces, gradient is less. Mountains, gradient will be more. This is ruling gradient. Next one is momentum gradient. Momentum gradient. It is generally provided in valley curves. Momentum gradient is generally provided in valley curves where a falling gradient meets a rising gradient. Generally, where a falling gradient meets a rising gradient. Momentum gradient, it is steeper than ruling gradient. Your gradient is more. Why you are providing something like this is, the thing is, when it is rising, it needs more amount of speed, right? So if I provide more falling gradient as more, then what happens is it goes faster so that it can easily rise. It can easily move on the rising gradient. So the momentum that is required for the movement of the rising gradient is you will get that momentum from falling on the downward gradient. That is momentum gradient. So momentum gradient, it is provided only in the case of valley curves, so that the train can move easily on the rising gradient because of the momentum that is obtained from the downward movement on the falling gradient. Fine. So that means if it goes faster like this, it can easily move upwards. That is the meaning of it. So momentum gradient, it is generally provided in valley curves. It is generally provided in valley curves where a falling gradient meets rising gradient. Fine. It is generally provided in valley curves where a falling gradient meets a rising gradient. The momentum required for the movement of train for the movement of train, for the movement of train in rising gradient, in rising gradient, rising gradient is obtained is obtained is obtained from the downward movement, from the downward movement on falling gradient, for the downward movement on falling gradient. Right? This is the use of momentum gradient, and it is steeper than it is steeper than ruling gradient. It is steeper than ruling gradient. Fine. Next one is pusher gradient. Pusher gradient. Next one is pusher gradient. So pusher gradient, whenever we talk about pusher gradient, it is provided in the exceptional cases. Pusher gradient is provided in the exceptional cases, generally 1 in 75. Fine. Pusher gradient is provided. Pusher gradient is provided in exceptional cases. Pusher gradient is provided in exceptional cases. When pusher gradient is provided in exceptional cases, as high as 1 in 75. 1 in 75. It can be, on planes is 1 in 150. It can be 1 in 75. It can be as high as that. Exceptional cases means you can't avoid those cases. You have to provide this one only. So one extra locomotive is used to push the train on these gradients. That means not one locomotives, there will be two locomotives. That means when vehicle is moving, the gradient is very high. So we'll use another locomotive to push it to the topmost point. So that is the thing. This is called pusher gradient. This is provided in the exceptional cases. It is steeper than momentum gradient. Generally pusher gradient is more than momentum gradient, which is more than ruling gradient, This is pusher gradient. So in gradients we have seen ruling gradient, momentum gradient, pusher gradient. Fine. Any doubts up to here? You can ask me. Any doubts up to here, guys? No doubt? Fine. Next one is grade compensation. When you will be providing grade compensation? I have already discussed this in highway engineering. Grade compensation when vertical curve is provided in additional to, or when longitudinal gradient is provided in additional to the horizontal curves, then will compensate the grade. Right? So will reduce the grade, that is called as grade compensation. Fine. So when gradient is provided in addition to horizontal curves, in addition, when gradient is provided in addition to horizontal curves, when gradient is provided in addition to horizontal curve, when gradient is provided in addition to the horizontal curve, there will be more resistance, there will be more resistance, there will be more resistance for the movement of train, there will be more resistance for the movement of train, there will be more resistance for the movement of train. When gradient is provided in addition to the horizontal curve, there will be more resistance for the movement of the train. So, so the gradient, the gradient is reduced, the gradient is slightly reduced, so gradient is slightly reduced, so gradient is slightly reduced, for better movement. So gradient is slightly reduced for better movement. This reduction is known as this reduction is known as grade compensation. This reduction is known as grade compensation. This reduction is known as grade compensation. So grade compensation equals to 0.304 d degrees for broad gauge track, 0.303 d degrees for meter gauge track, and 0.302 d degrees for narrow gauge track. So this is grade compensation. Compensated grade would be gradient minus grade compensation. Any doubts in this? You can ask me. Any doubts, guys? Any doubts? Minimum value is same here, 1 in 500 to 1 in 1000. For drainage purposes, obviously you will provide that. So it is same. Here what is the gradient? Have I given any gradient? This is d degrees. This is not gradient. Grade compensation is independent of gradient. It is d degrees only. Of course, there is no minimum value of 4% here. There is nothing like that. This is how you will be calculating compensated grade. How much time we can compensate it? It's whatever the value you get compensate that much time. There is no minimum value here. Minimum value is in highways. The lesser the gradient, the better it is. Any doubts? No doubt? Fine. In question is, if ruling gradient is 1 in 150, there is curve also with gradient of, with degree of 4 degrees, with degree of 4 degrees. There is curve also with degree of 4 degrees. What is grade compensation? What may be the maximum gradient provided on broad gauge track? What is grade compensation? What is grade compensation? What is grade compensation? What may be the maximum gradient? What may be maximum gradient? What may be maximum gradient provided on broad gauge track? What may be maximum gradient provided on broad gauge track? Please give me the answer. Please give me the answer. One in 197.36. So what is grade compensation? Solution. What is grade compensation? Grade compensation for broad gauge track, that is equals to 0.304 d degrees, that is 0.304 multiplied with 4, that is 0.0016. 0.0016. This is grade compensation. Compensated grade would be equals to gradient minus grade compensation. Fine. So gradient is 1 in 150, 1 upon 150 minus 0.0016. What you are getting? 1 in 197.36. So 1 upon 197.36. This is the gradient that you will provide. You will not provide this one, you will provide that gradient. So this is how you will solve grade compensation questions. So with this I am closing railway engineering. In railway engineering we have seen what is the type of the rails, and then components of the rails, and we have seen geometric design of the rails. We have seen points and crossings, crossovers, and then we have seen today what we have seen. Today we have seen gradient, and then traction and tractive effort, and different types of resistances, all those things. So a decent 6 lectures I have taken in this. So please go through everything. If you are having any doubts, you can go ahead and ask. If not, this is Karthik Mandalapu signing off. Tomorrow I will be starting airport engineering. Thank you. Any doubts, guys? I don't know, Prachi. If airport is completed by tomorrow, tomorrow will be your last lecture. If not, day after tomorrow. That's it. Yeah, please go ahead and ask. What is the doubt, Narendra? What is the doubt? It's not can't, containment or cantonment they'll say. Like what can't? Agra can't. That has nothing to do with the super elevation. That is containment or cantonment they'll say. That is a different word. For railway station they can use cantonment also. That is the meaning of it. It has nothing to do with this super elevation and all those things. No. It has nothing to do with super elevation. It's like and Kanpur Central, Lucknow Junction. See, there are different types of railways. There will be junctions. Junctions, it's like different types of tracks. Vehicle, generally they'll keep a South Central Railway. South Central Railway, I'll say it is at Hyderabad. Why? Because people, I mean trains that is passing through the different routes, they'll make sure that everything meets at Hyderabad, because Hyderabad is a famous location, many people wants to come over there and they want to go, so that is the reason they'll make a location out of it. So that is South Central Railway location, Hyderabad, Chennai. So for major cities, they'll club all the tracks over there. That is why it is called as junction. Central Railways means it can be at the central position. That is the reason it is called as Central Railways. It's Kanpur Central and all those things. That is a different word. Cantonment is a word. Go and Google it. That indirectly means it's a station, or it's a place where different vehicles are meeting. That is a meeting point. Cantonment, containment. Next. Fine. Yeah, this is what generally you observe. Initially, if when you become railways engineers, before and all, you are the one who takes care of stations, tracks and all those things. And right now I don't know, they are saying they'll conduct different examination for it, but I don't think so they'll conduct different examination. They are going to privatize the railways. That is the idea. If railways is privatized, there is a possibility that, if you ask me, obviously the standards will be improved, at the same time cost will be improved here. The thing is, many people in India who can't afford buses, cars, the only mode for them is trains. They are happy traveling in trains, because whatever that is 700, if it is in the bus, it comes out of 200 in the trains. So this is the cheapest mode of transport, and it serves many people. And suddenly if they privatize the railways, of course the salaries will be given by the private people, but the cost will be increased. Why? They look it from the profit point of view. So it's a debatable thing, privatization of railways, but I prefer don't privatize railways, because it's huge thing. If it is made into a profit market, then people can't survive, poor people can't survive. Then it will be like all rates will be increased, everything will be increased, transport, everything. That's what I prefer. Let's see what central government does. And so till that time, bye bye, have a nice day. Let's see guys, bye, have a nice day.